Hi everyone, today we are going to study what is calling sequence and parameter passing. First we will look what is calling sequence. Calling sequence is maintaining the subroutine called stack. Calling sequence in general have three components. The code executed by the caller immediately before and after subroutine call is called calling sequence. Then this two terms, prologue and epilogue. Prologue means code executed at the beginning of the subroutine and epilogue means code executed at the end of the subroutine. So these are the three components of calling sequences. So we can see in this example the calling sequence code, calling sequence code you can see in this. And the prologue code is the beginning and then we do foo body and then we do epilogue code. So the term calling sequence is used to refer to the combined operation of the caller, prologue and the epilogue. Maintenance of the subroutine call stack is the responsibility of the calling sequence. So what are the procedures that are going through in the calling sequence? So calling sequence refers to the code executed by the caller immediately before and after a subroutine call and of the prologue and the epilogue of the subroutine itself. Then the calling sequence is the code a caller executes to set up a new subroutine. So what are the responsibilities of calling sequence? On the way in, it will pass parameters, save return address, change program counter, change stack pointer, save registers that might be overwritten, changing frame pointer to new frame and initializing code for new objects in the new frame. On the way out, what is going on the calling sequence? It passing return parameters or values, execution finalization, code for local objects, deallocating the stack frame, restoring registers and restoring the PC. So these are the responsibilities of a calling sequence. On the way in, these are things going on, and the way out also like this the process is going on. Some of the tasks means passing parameters must be performed by the caller because they differ from call to call. Most of the tasks can be performed either by the caller or the callee. The space is saved if work is mostly done by callee. Anything done in callee appears only once in the target program. Anything done by the caller has to appear before and after every call in the final compiled code. So saving and restoring registers the problem. Some registers such as SP and FP are clearly different in and out of a subroutine. For general purpose register used in caller or callee, we can say that main R1 is equal to 10, call foo R2 is equal to R1 and the foo body contains R1 is equal to 20. To execute correctly, R1 needs to be saved before foo and restored after. So this is the saving and restoring registers. Saving and restoring registers, the solution 1 is save, restore in the calling sequence at the caller. So the main T1 is equal to R1, then call for R1 is equal to T1, calling sequence is there. Solution T is save, restore in the prologue and epilogue at calling. So for T1 is equal to R1, this prologue, then R1 is equal to 20, R1 is equal to T1, this epilogue, then return. The stack pointer SB points to the first unused location on the stack or the last used location depending on the compiler and the machine. Then the frame pointer is there, FP. It points to a location near the bottom of the frame. The space for all arguments is reserved in the stack even if the compiler passes some of them in registers. The callee will need a place to save them if it calls a nested routine. This is a typical calling sequence. Frame pointer and stack pointer is there. Then we draw in it growing upward on the page. The stack actually grown downward towards lower addresses on most machines. Arguments are assessed at positive offsets from the frame pointer FP. Local variables and temporaries are assessed as negative offsets from the FP. Arguments to be passed to called routines are assembled at the top of the frame using positive offsets from the stack pointer. What needs to be done in the calling sequence? Before the subroutine code can be executed, you have to set up the subroutine frame, compute the parameters and pass the parameters. You have to save the return address, then save registers, changing SP and FP to add a frame for the subroutine, changing PC, start running the subroutine code, execute initialization code when needed. After the subroutine code is executed, caller code after the routine epilogue, remove the subroutine frame, passing return result or function value, finalization code for local objects, deallocating the stack frame, that is restoring FP and SP to their previous value, restoring saved registers and PC. Some of the operations must be performed by the caller, others can either be done by the caller or callee. To maintain the stack layout, the calling sequence operation is as follows. The first is the caller. What are the process that is done in caller side? That is, saves any caller, saves registers whose value will be needed after the call. Then computes the values of the arguments and moves them into the stack or registers. Then compute the static link and passes it as an extra hidden argument. Uses a special subroutine call instruction to jump to the subroutine, simultaneously passing the return address on the stack or in a register. So to maintain the stack layout, in this prologue, the callee allocates a frame by subtracting an appropriate constant from the SP and saves the old frame pointer into the stack and assigns it an appropriate value, saves any callee, saves registers that may be overwritten by the current routine. After the subroutine has been completed, the epilogue, it moves the return value into a register or a reserved location in the stack. Okay. Then second is it restores callee save registers if needed. Then it restores the FP and the SP. Jump back to the return address. Finally, the caller, it moves the return value to wherever it is needed. It restores caller saves registers if needed. Many parts of the calling sequence, prologue and epilogue, can be omitted in many cases. What do you mean by inline expansion? Inline expansion, in some languages, programmers can actually flag routines that should be expanded inline. Stack overhead is avoided. The example in C++ or C99 is shown. Ada does something similar, but keyword is pragma inline max. So this is the syntax using inline expansion in C++ and Ada. Next we going to parameter passing. What do you mean by parameter passing? Most subroutines are parameterized. Parameter names that appear in the declaration of a subroutine are known as formal parameters. Variables and expressions that are passed to a subroutine in a particular call are known as actual parameters. Actual parameters is also known as arguments. Then parameter passing mechanism have three basic implementations: value, reference, closure or name. Parameter passing modes. Some languages including C, Fortran, ML, Lisp define a single set of rules that apply to all parameters. Other languages including Pascal, Modula, Ada provide two or more set of rules corresponding to different parameter passing modes. Two most common parameter passing modes are call by value and call by reference. Suppose x is a global variable in a language and we wish to pass x as a parameter to subroutine p of x. We may provide p with a copy of x value or we may provide it with x address. With the value parameters, what is happening? Each actual parameter is assigned into the corresponding formal parameters when a subroutine is called. Then, from then on, two are independent. So, in value parameters, what actual parameter is assigned into the corresponding formal parameters. With reference parameters, if the actual parameter is visible within the subroutine under its original name, then the two names are aliases for the same object and changes made through one will be visible through the other. The two techniques used for argument passing modes is call by value. It means that going into the procedure. Then call by result, copy going out of the procedure. Then call by value result, copy going in and again going out. Then call by reference, pass a pointer to the actual parameter. Call by name works like call by reference for simple values. For expression, it will evaluate an actual parameter on every use. If parameter passing modes, if y is passed to foo by value, then the assignment inside foo has no visible effect. Y is private to the subroutine. So here you see the program x is equal to integer, procedure foo y integer, then y is equal to 3 print x, then x equal to 2 foo of x print x. So if y is passed to foo by call by value, this program prints 2 twice. Y is private to the subroutine and the program prints what? 2 twice. If y is passed to foo by reference, then the assignment inside foo changes x. The assignment inside foo changes x. Y is just a local name for x and the program prints 3 twice. Call by value result, copy call by value, result x into y at the beginning of foo and y into x at the end of foo. So the program would print 2 and then 3. Then another is call by name by textual substitution. Call by name works as call by reference when actual parameter is scalar but different when actual parameter is expression or array, then actual parameter is re-evaluated on each axis. Call by name parameter passing re-evaluates actual parameter expression each time the formal parameter is read. Okay, then resulting semantics. If actual is a scalar variable, it is passed by reference. If actual is a expression or array, then actual parameter is re-evaluated on each axis. We can see that call by value and call by name program. Here in this program, if it is called by value, it will print 10, 10, and if it is called by name, it will be output will be 10, 11. Then call by value or call by result. Like call by value result copies the actual parameter into the formal parameter at the beginning of subroutine execution. Unlike call by value, it also copies the formal parameter back into the actual parameter when the subroutine returns. Value result will copy call by value result x into y at the beginning of foo and y into x at the end of foo. Assignment of 3 into y would not affect x until after the inner print statement. So the program would print 2 and then 3. In Pascal, parameters are passed by value by default. They are passed by reference if preceded by the keyword were in their subroutine's headers formal parameter list. Parameters in C are always passed by value, though the effect for arrays is usual because the interoperability of arrays and pointers in C. To allow a called routine to modify a variable other than an array in the caller's scope, the C programmer must pass the address of the variable explicitly. Call by reference. Fortran passes all parameters by reference. If a built-up expression appears in an argument list, the compiler creates a temporary variable to hold the value and passes this variable by reference. A Fortran subroutine that needs to modify the values of its formal parameters without modifying its actual parameters must copy the values into the local variables and modify those instead. Then there is call by sharing. What is that? Java uses call by value for variables or built-in type, all of which are value, and call by sharing for variables of user-defined types, all which are references. A Java subroutine cannot change the value of an actual parameter of built-in type. When desired parameters in C# can be passed by reference instead of labeling both a formal parameter and each corresponding argument with the reference or out keyword. In contrast to Java, therefore, a C# subroutine can change the value of an actual parameter of built-in type if the parameter is passed ref or out. Another is call by sharing. Languages like Clue uses this mode call by sharing. The actual and formal parameters refer to the same object. It is different from call by value because although we do copy the actual parameter into the formal parameter, both of them are references. If we modified the object to which the formal parameter refers, the program will be able to see those changes through the actual parameter after the subroutine returns. Call by sharing is also different from call by reference because although the called routine can change the value of the object to which the actual parameter refers, it cannot change the identity of that object. Then purpose of call by reference. In a language that provides both value and reference parameters, these are the two principal reasons why the programmer might choose call by reference. First, if the called routine is supposed to change the value of an actual parameter, then the programmer must pass the parameters by reference. Conversely, to ensure that the called routine cannot modify the argument, the programmer can pass the parameter by value. Second, the implementation of value parameters requires copying actuals to formals, potentially time-consuming operation when arguments are large. Reference parameters can be implemented simply by passing an address. Then read-only parameters. To combine the efficiency of reference parameters and safety of value parameters, Module2 provides a read-only parameter mode. Any formal parameter whose declaration is preceded by read-only cannot be changed by the called routine. The compiler prevents the programmer from using that formal parameter on the left-hand side of an assignment statement, reading it from a value or passing it by reference to any other subroutine. Small read-only parameters are actually implemented by passing a value. Large read-only parameters are implemented by passing an address. The equivalent of read-only parameters is also available in C, allows any variable or parameter declaration to be preceded by the const. Const variables are elaboration time constants. Const parameters in C parameters are particularly useful when passing address. So void append to log constant huge record pointer r append in log my record. Here the keyword const applies to the record to which r points. The callee will be unable to change the record contents. Parameter modes in ADA. ADA provides the parameter passing modes called in, out and in, out. In parameter pass information from the caller to the callee. They can be read by the callee but not written. Out parameters pass information from the caller to the caller. In ADA 83 they can be written by the callee but not read. In ADA 95 they can be both read and written and then begin their life uninitialized. In out parameters pass information in both directions. They can be both read and written. Changes to out in or in out parameters always change the actual parameters. So this is closures as parameters. A closure needs to include both a code address and a referencing environment because in a language with nested subroutines. ADA 83 did not permit subroutines to be passed as parameters. Fortran has always allowed subroutines to be passed as parameters but allowed them to nest beginning in Fortran 90. Subroutines are routines passed as parameters, returns as results in function languages. C and C++ have no need of subroutine closures because their subroutine do not nest. Techniques used in argument passing. The Fortran uses call by reference. Early Fortran passing a constant. Algol 60 has a call by value, call by value result. ADA uses different designation in, out and in, out. For scalar data types, in is the same as call by value, out is same as call by result and in out is same by call by value result. For compound data types such as arrows, these can be implemented as above or using call by reference. Lisp and Smalltalk use call by value with the pointer semantics. Java uses call by value with just copying for primitive values and pointer semantics for objects. This is the parameter modes in ADA. This is parameter modes, representative languages, implementation mechanism and permissible operations. So I will come with the generic subroutines and modules in next class. Till then, bye.